we want to evaluate the given definite integral using integration by parts. The integration by parts formula is here that states the integral of u dv equals u times v minus the integral of v du. So the integral of u dv is difficult to integrate, and hopefully after applying this formula, the integral of v du will be easier to integrate. The first thing we should do is move x to the negative 2 up to the numerator, which changes the sign of the exponent, giving us the integral of x to the power of negative 2 times natural log x dx. We want to select u so that differential u is simpler. We want to select dv so that we can easily integrate to find v. So in this case, let's try letting u equal natural log x. Since natural log x is not easy to integrate, it wouldn't be a good choice for dv. So if we let u equal natural log x, then that means differential v, or dv, would be equal to x to the negative 2 dx. So if we let u equal natural log x, then differential u, or du, is equal to u prime times dx, which should be 1 divided by x dx. And if we let dv equal x to the power of negative 2 dx, we would integrate both sides to find v. So if we integrate x to the power of negative 2, we would add 1 to the exponent and then divide by the new exponent. That would give us x to the power of negative 1 divided by negative 1, or just negative x to the negative 1. Now we can apply the integration by parts formula. So this given integral is equal to u times v. Well, here's u and here's v, so natural log x times negative x to the negative 1 would be equivalent to negative 1 divided by x natural log x. And we do have a definite integral, so we'll have to evaluate this at 4 and 1 and then find the difference. And then we still have minus the integral of v du. So here's v and here's du. So we'd have negative x to the negative 1 times 1 over x dx. And let's write this as x to the negative 1 dx. Of course, the limits of integration are still from 1 to 4 here. And then we have minus and negative. That'll be plus the integral of, and here we're multiplying, so we add the exponent, so we'll have x to the power of negative 2 dx. So we have negative 1 divided by x natural log x plus the antiderivative of x to the negative 2. We'd add 1 to the exponent. That would give us x to the negative 1. And then we divide by negative 1, so we'll have negative x to the negative 1. And we'll have to evaluate this at 4, then 1, then find the difference. Let's finish this on the next slide. Let's go ahead and write this as negative 1 divided by x natural log x. And then let's write this as minus 1 over x. So when x is 4, we'd have negative 1/4 natural log 4 minus 1/4. And then when x is 1, we have negative 1 over 1, which is negative 1, times natural log 1 minus 1 over 1, which is 1, which gives us negative 1/4 natural log 4 minus 1/4. Natural log 1 is equal to 0, so this simplifies out. So we just have minus negative 1 or plus 1. So the exact value would be negative 1/4 natural log 4, and then negative 1/4 plus 1 would be plus 3/4. But let's also get our decimal approximation for this. We'd have negative 1/4 natural log 4, and then plus 3/4. So we have approximately 0.4034. And because we had a definite integral, we can actually check this on the graphing calculator. To do this, we'll press Math, option 9 for function integration. And this is the newer version of the TIE4. So if you have an older version, it will look a little bit different. If I press enter, notice how we see an actual integral here. So we first enter the lower limit of integration, which is 1, right arrow. Upper limit of integration is 4, right arrow. Let's enter the integrand in this form here. So we have x raised to the power of -2, right arrow to exit the exponent, and then we have natural log x, close parenthesis, right arrow, the variable of integration, which is x, and enter. And notice how this does verify our result, as we see here as our decimal approximation. I hope you found this helpful.